Hello everyone. In today's class, I will be discussing about secondary memory and its types. So, secondary memory is also known as external memory or storage memory or auxiliary memory or backup memory. It is used for storing data and instructions permanently. It is also used for carrying data from one computer to another. Secondary memory is not directly accessible to CPU. It is usually slower for read or write, cheaper, and used in larger storage capacity. So, coming to the types of secondary memory, basically secondary memory are of two types, sequential access and direct access. But overall we can say the main classification of secondary memory is in terms of magnetic or optical memory. So, magnetic memory, basically as I've told you that secondary memory can be classified in terms of sequential access and direct access, and in sequential access we have magnetic tape, and in direct access we have magnetic memory as well as optical memory. So I'm just concluding that overall classification I can also say that it is in terms of magnetic memory and optical memory. So what is magnetic memory? The magnetic memory uses the property of magnet for storing data, that is 0 or 1. It is in use since first generations of computer. It contains data storing surface coated by magnetic oxide. So the first type of magnetic memory that I am going to discuss is magnetic tape, which is also called sequential access memory. So, magnetic tape contains thin plastic ribbon. Only one side of the ribbon is used for storing data. The data storing side is coated by magnetic oxide. It is a sequential access memory, as I've told you. So, the data read or write speed is slower. It is mainly used for storing audio, video, and backup data. It is highly reliable and it requires magnetic tape drive for reading and writing data. So it has the storage capacity of 100 MB to 200 GB. The width of the ribbon also varies from 4 millimeter to 1 inch. So this was the magnetic memory, this was the magnetic tape that I discussed, and it comes under sequential access memory. Under direct access also we have magnetic memory. So the next magnetic memory that I am going to discuss is hard disk drive. So a hard disk is made of aluminum base with a thin coating of magnetic material or iron oxide, the magnetic material, that is iron oxide, over it. Now, this hard disk is a surface device. Its surface is divided into a number of concentric tracks, and each track is divided into a number of sectors as shown in this slide. Tracks and sectors do not have physical existence on the surface of the disk. They are logical things. So to increase, if I want to increase the storage capacity, so several hard disks can be used, which are also called platters, for this purpose, and these platters are mounted on a common drive to form a disk pack. Data bits are stored serially on each track. The set of the same number of tracks on different disks of a disk drive unit will lie on the surface of a imaginary cylinder. The disks are addressed by a drive number, cylinder number, that is cylinder number is the track number, surface number and sector number. Now let me discuss the several key components that the hard disk is made up of. So coming to the point, platters. What is platter? Platter basically they are metallic discs where one or both sides of the platter are magnetized, allowing data to be stored. So the platter spins thousands of times a second around the spindle. There are several platters, there can be several platters with data stored across them. Then comes head. The head reads magnetic data from the platter. For a drive with several platters, there may be two heads per platter, allowing data to be read from top and bottom of each. The next term is actuator arm. It is used to move the read heads in and out of the disk so that data can be read and written to particular locations, and you can access data in a random fashion. You don't need to read your way through the entire disk to fetch a particular bit of information. You can jump right there. So the seeking time here is very low. Then there is power connector. So the power connector, here I've shown. Then there is power connector. The power connector provides electricity to spin the platters, move the read head and run the electronics. Then there is IDE connector. It allows for data transfer from and to the platters. Then we have jumper block. It is used to get the disk working in specific ways. So these were the key components of the hard disk, that is platter, spindle, head, actuator arm, then this IDE connector, jumper block, etc. Now how this hard disk works? This platter spin around the spindle and the data is requested to be read from a particular area of a platter. The actuator arm moves the read head to that track. Once the data sector that is required has spun around and under the read head, the data is read. So read data is sent from the ID connector to the main memory. Now the time required to move the read or write head to the specified track is called seek time. This depends on the initial position of the head relative to the track specified in the address. The latency or search time is the time required to rotate the specified sector under the head. The sum of the seek time and the latency time is called the access time. So the storage capacity of hard disk drives can be up to 4 TB. Storage capacity per platter can be up to 1 TB. The speed of rotation of the platter is 3600 RPM to 15,000 RPM, etc. So this was all about the hard disk. Now I will discuss the main principle that is actually happening inside the hard disk. So what happens, how the data gets stored in the hard disk, that is 1 or 0 gets stored in the hard disk. Now when if I want to store 1 or 0, then by applying current pulses of suitable polarity to the magnetizing coil of read or write head, So read or write head has a magnetizing coil around it. So by applying current pulses of suitable polarity to the magnetizing coil of read or write head, digital information 1 or 0 is stored on the magnetic coating of the magnetic disc, which is comprising of iron particles. Therefore, the logic 1 or 0 depends on the direction of magnetization of iron particles of the magnetic disk, which comes under the read or write head. Now, what happens during read operation? During read operation, the magnetized surface of the disk passes under the read or write head. Due to the movement of the magnetized disk surface relative to the coil of the read or write head, electric pulses are generated across the coil. The polarity of the electric pulses depends on the direction of magnetization of very small areas of the magnetic film on the disk surface, which were created while writing data in the form of 0 and 1. So the pulses are generated across the coil. So in this way we read or write data in the hard disk. Next magnetic memory is floppy disk. So this floppy disk, it contains single plastic disk. Initially it was used as a main storage device, but nowadays it is used for carrying data from one computer to another. It requires floppy drive for its operation. It is not reliable as hard disk because the data storing surface is exposed, so it may be affected by dust particles and magnetic field. The next I'm going to discuss about the optical memory, and in optical memory the first classification comes is CD. So basically I've told you that this secondary memory is divided into sequential memory and direct access memory. In sequential access memory we have magnetic tape, and in direct access memory we have everything that we are discussing here, that is hard disk, floppy disk, CD-ROM, Blu-ray, DVD, everything. And overall classification I have told you that it is in terms of magnetic memory and optical memory. Till now we have discussed about all the types of magnetic memory. Now we will be discussing about optical memory, and here is CD. So CD stands for compact disc. You might know this, you all might know this thing. So what happens here? Laser beam is used to write information to or read information from an optical disc. A laser is highly focused, highly controlled beam of light, either visible or infrared, which is more commonly used in storage devices. An optical disc has very high storage density and data integrity. It is relatively inexpensive and has a long life of at least 20 years. So its drives are inherently simple and inexpensive. The read or write head does not touch the disk surface. It is several millimeters away from the disk surface. Hence, there is no disk wear. The drawback of an optical disk system is its longer access time compared to hard disks. So this CD-ROM, it is compact disk read-only memory. The disk is made of a resin such as polycarbonate and it is coated with highly reflective surface, usually aluminium. The disk size is 5.25 inch diameter, and the information is written to the disk by burning pits on the disk surface with controlled laser beam. So information is read from the disk using laser beam. The reflected laser is sensed by photodiode to read data. The intensity of the reflected light of the laser changes as it encounters a pit. A pit spreads the light so that the photodiode receives little reflected light. On the other hand, the surface without a pit reflects sufficient light to the photodiode. Thus, the change in reflected light is sensed and converted into electrical pulses for data reading. CD-ROMs do not use concentric tracks, rather they use single spiral track. So the capacity of CD-ROM is 650 MB and the data stored in CD-ROM disk is isolated from the outside world by a storing protective layer of plastic at the top of the surface. So we have three types of CD, that is CD-ROM, that is compact disc read-only memory, CDR, that is compact disc recordable, and CDRW, that is compact disc rewritable. So CD-ROM, the data on these CDs are recorded by the manufacturer. CDR, data can be written by the user once on the CDR, cannot be deleted or modified later. And CD rewritable, that is data can be written and deleted on these optical discs again and again. So the next is DVD. We know the full form of DVD is digital versatile disc. It is again the next optical memory. So it has much more storage capacity than that of CD. It uses laser beam of shorter wavelength as compared to that used in CDs. A CD drive uses an infrared laser beam with a wavelength of 780 nanometer, whereas laser used in a DVD has a wavelength of 635 nanometer. So we have different types of DVD, that is DVD-ROM, DVD-R and DVD-RW, that is DVD rewritable. So the DVD-ROM, its basic structure is similar to that of CD-ROM. The different layers are the bottom layer, which forms its base, is polycarbonate plastic. The next layer, which is a reflecting layer, is the aluminium. Then there is protective acrylic layer, and at the top there is label. Next is DVD recordable. Here its basic structure is similar to DVD-ROM, except that it contains a kind of dye material on the track. Pits are formed in dye material. The user can write only once on the disk and read as many times as he wants. And the last one is DVD read and write, that is rewritable. Its basic structure is similar to CD rewritable. It uses an alloy of silver, indium, antimony, etc. and tellurium. So the next optical memory that I'll be discussing is Blu-ray disc. The capacity of this disc is 25 GB and 50 GB for single layer and double layer disc respectively. That is 25 GB for single layer and 50 GB for double layer disc. So Blu-ray disc are once writable disc. That is Blu-ray disc are again classified as BDR, that is Blu-ray disc recordable, which are once writable disc. Then we have BDRW, that is Blu-ray disc rewritable, which are rewritable disc, and it is suitable for backup or archival memory. So the format that offers more than 5 times the storage capacity of traditional DVDs and can hold, as I've told you, it can hold up to 25 GB for single layer and 50 GB for dual layer disc. So these are the 3 types of optical memory that I've discussed: CD, DVD and Blu-ray disc. And the last comes the flash memory. So flash memory, it is electrically erasable and reprogrammable. It is inherently non-volatile memory. Unlike EEPROM, flash memory uses one transistor memory cell, resulting in high packaging density, lower cost and higher reliability. In EEPROM, it is possible to read and write the content of a single cell. In a flash memory device, it is possible to read the content of a single cell, but it is not possible to write to a single cell. It allows to write an entire block of cells. So before writing to a block, its previous contents are erased. That is, it is not byte by byte erasable like EEPROM. The power consumption of flash memory is very small. A single flash memory chip may not have large capacity, and hence memory modules consisting of several memory chips have been developed. So these flash memory modules are available in 2 forms, that is flash cards and flash drives. So typical capacities of flash cards are 128 MB to 64 GB. They are also available in postage stamp size. Some special purpose flash cards are available up to 32 GB and 64 GB cards are under development. Typical capacities of flash drives are up to 512 GB. They come in the shape of a stick of few centimeters long. They are also called pen drive or thumb drive, etc. So this was all about secondary memory. I hope you understood the topic. I'm ending this class here. We'll continue. We'll start 8085 microprocessor in my next video lecture. Thank you.